Hi, in this video we will solve these trig equations. So let's solve the first equation. We have 4 cos square theta equal to 2. Okay, so to solve this equation, first we have to isolate the trig function, that is the cos theta. So we have to divide both side by 2, right? So divide both side by 2. So you will get cos square theta equal to 2 over 4. Okay, so now we have the cos squared, right? So square root on each side, so you will get cos theta equal to plus or minus square root of 2 over 4, which is equal to plus or minus, so square root 2 over 2. The square root of 4 is just 2. Okay, so we have cos theta equal to square root of plus or minus square root of 2. So we have the two solutions. So two equation, cos theta is positive square root 2 over 2, and we have the cos theta equal to negative square root 2 over 2. Okay, so we have to find the solutions. Since cos theta equal to positive square root over 2 on the unit circle, so square root 2 over 2, so we have the x equal to, draw the line, square root 2 over 2. Okay, so we have the two solutions, one is in first quadrant and the second one is in fourth quadrant. So in the first quadrant, cos theta equal to root 2 over 2 when theta is 5 over 4, and these two angles are symmetrical. So we have the remaining angle is, this one is a negative 5 over 4, so that is the negative 5 over 4. But to find the angle which is in positive angle, we have to um, so this one is 7 pi over 4. So by subtracting the 2 pi minus 2 pi equal to, so this angle equal to 2 pi is so 2 pi can be written as 8 pi over 4, right? So that is 8 pi over 4 minus pi over 4, that is a 7 pi over 4. So we have the angle pi over 4 and 7 pi over 4 whenever cos theta equal to positive root over 2. Okay, but we have to find the all the solution, there is no specific domain is given. So we have to add the period of the cos. The period of the cos equal to, the period of the cos is 2 pi, so that means we have the solution, so at each period, right, each cycle, that is the pi over 4, plus we have to add 2 pi and any multiples of n, that is the n. Also we have the 7 pi over 4 plus 2 pi any multiples of n. So this is the general solution of this equation. Okay, so now let's solve this equation. Cos theta equal to negative root 2 over 2. So cos theta equal to negative root over 2, what is theta? When we have the cos of theta equal to negative root over 2, so let's use our unit circle. So since cos is related to x, right, so we have draw the line now, x equal to negative root 2 over 2. So let's draw the x equal to negative root over 2. Since this line intersects the uh, this unit circle at 2 points in the second quadrant and first quadrant, right? So this one and this one. Okay, now, so the cos theta equal to square root of 2 when theta equal to, so it is in the second quadrant, right? That means so that is we have in the first quadrant we have pi over 4, then the symmetric about this angle is y axis, that is, so this one is the 2 pi over 4 and this one is the 3 pi over 4, so that is 3 pi over 4, and we have, so these angles are symmetric about x-axis. So this is the pi over 4 and this is the pi over 4. So this pi angle is uh, 4 pi over 4, and this one, this angle pi over 4, adding pi over 4 to the 4 pi over 4, we have the 5 pi over 4. Okay, so these are the solutions in 0 to 2 pi, but this we have to find all the values, so we have to add the period of the cos function. So that is 3 pi over 4 plus the period of the cos function is 2 pi and multiples of any 2 pi, and 5 pi over 4 and multiples of 2 pi n, multiples of 2 pi n, where n is the integer. Okay, so these are the solutions of this equation. Okay, now let's approximate the values of this equation. 3 sine square theta, 3 sine square theta equal to sine theta. So we have 3 sine square theta equal to sine theta. So to isolate this equation sine theta, we have to subtract sine theta on each side. So that is the 3 sine theta sine square theta minus sine theta equal to 0. Subtracting sine theta on each side. Now you can see, you can factor the sine theta from these two terms, right? So now you can factor the sine theta here. So that is 3 sine theta minus 1 equal to 0. So now you can use the zero product property. We have sine theta equal to 0 and 3 sine theta minus 1 equal to 0. So sine theta equal to 0, we have theta equal to, on the unit circle, so sine theta is 0, so sine is related to y-axis, right? So that is sine is 0 at theta equal to 0 and theta equal to pi. So that is sine theta equal to 0 and theta equal to pi. So we have to find all the values. So we have to add the period of the this sine function. So since the sine function has the period 2 pi, so we have to add 0 to 2 pi and the multiples of 2 pi n and pi plus 2 pi n. Okay, so therefore the solutions are theta equal to 2 pi n and pi plus 2 pi n. Now let's solve this equation. 3 sine theta minus 1 equal to 0. So adding 1 on each side, you will get to 3 sine theta equal to 1, and dividing both sides by 3, you will get to sine theta equal to 1/3. But 1/3 is the not exact value. We have to use calculator. So here uh, um, doing inverse function on each side. So theta equal to sine inverse 1/3. Okay, so now use the calculator and find the exact value. Before that, let's make a unit circle here. So on the unit circle, so sine is related to y-axis. So draw the y equal to 1/3 here. You can see y equal to 1/3. Let's say this is the y equal to 1/3. We have the two solutions in the first quadrant and the second quadrant. Okay, but whenever we use the inverse trig function, usually calculator gives the solutions in the first and fourth quadrant only. Okay, so that means we will calculator will give us the only solution in first quadrant only, so we have to use the solution as a reference angle and find the other solution. Okay, let's use the calculator, enter, and press second sine 1/3. Okay, so this is 0.33985 radians. So this angle theta equal to 0.33 2.33985 radians. So this is the angle. This angle is 0.33985 radians. This angle. So we have to find the other angle. These two angles are symmetric about y-axis. So you can find the other angle by um, uh, subtracting from the pi. Okay, so use the calculator. So second pi minus answer. So that is 2.80175. So this angle is, the second angle is theta equal to 2.80175. Okay, so this angle is 2.80175. Since we have to find all the solutions, so we have to add the period of the sine function, that is the 2 pi n. So these are the solutions. Okay, so now this equation has the solution. So theta equal to 2 pi n and pi plus 2 pi n, and we have the theta equal to 0.33985 radians plus 2 pi n, and the theta equal to 2.80175 radians plus 2 pi n.